Fergal, we're back. We're so back. We're back in the events that you and I have sat down a couple of times in the past on this podcast to talk about the state of AI. I went back and looked at the dates actually. Yeah, we first sat down in June 2023. This was the period of time when we were talking about things like AI being potentially a blurry JPEG of the web, something you push back on actually. Yeah, the emergence of agents and so on. We checked in again in August 2023 when we started talking about the prospect of maybe this leading to super intelligence, or were we starting to see like reasoning capabilities come out of these models? It's August 2025, so we figured it'd be a good time to check in again. I would love to hear at a high level from you to start with. What do you think are the most important changes that we've seen in the AI landscape over the last year or so?
Yeah, I mean, if I was to summarize like the journey so far in the state of play, I'd be kind of like, okay, so GPT-3 came out and it was cool, and then 3.5 came out and we could take these cool models and get them to do useful things, and then GPT-4 came out, which was like a big scaled up version, and suddenly it was starting to get like intelligent at a whole lot of things, and it was like maybe just scaling up that pre-training is going to make models that are like more and more generally intelligent. And this is the whole like, situational awareness, I think, captured this really well, which is that you continue to extrapolate forward pre-training and build bigger and bigger clusters, and just higher and higher IQ models will come out the other end. And it looks like that hasn't worked out. The people call it the Orion project. What was originally going to be GPT-5, and then they changed to GPT 4.5, was this like big attempt to scale up this big multi-data center model. And like, it's a good model and it was smart and everything, but it wasn't this huge breakthrough with like, another 50 IQ points or something like that. In a way, that was really encouraging about that happening. Something that happened around the same time is, or slightly before, is like reasoning models. Like people started to figure out that you could do test time compute. You just run these models for a long time and they'd be able to reason their way through problems. That kind of happened around the same time. And if it's interesting to think about, if that hadn't happened, what are we talking about? We'd be like, oh, the whole AI thing is completely over, pre-training stalled, you don't know what to do. Or would we be like, actually, GPT 4.5 was a pretty good model, But either way, reasoning happened, and you just get these models to like think for a long time and they get better at solving problems. And it now really feels like we're not in a world of scaling up pre-training. Instead, we're doing reasoning models. Then we're using reinforcement learning to have the models reason for a bit, and then, did I get the problem right? If so, well, that type of reasoning looks good. I should do that the next time, and to grind away and learn. So people are still doing big capex, big data centers, but now they're talking about it more as like massive reinforcement learning, post-training kind of farms, rather than just scaling pre-training. I mean, scaling pre-training might still happen, but it feels, from what I can see, as the less promising trajectory now. So
Yeah.
it's been a bit of a roller coaster,
Yeah, yeah. I'm curious to dig into some of that, and maybe we'll just go back over some of it to make it clear as well. So, if we go back a year ago, you referenced situational awareness. It was this paper that Leopold Aschenbrenner put out, and it kind of set out the stall of, hey, here is where, if the pre-training trends continue, we are on a path to super intelligence. That was the core of what I took from what he said. And you're saying that has turned out to not be true. So maybe just very briefly explain like the difference between pre-training and post-training, because that seems like the big thing. Like pre-training kind of stalled, but post-training seems to have picked up the slack. And so on a net level, AI continues to make progress. Explain what's behind that, or why did that happen?
So pre-training is this idea that like you have this objective function, this thing that tells you how good the model is. And with pre-training, what you typically care about is like next token prediction. How good is it at like predicting the next token in a sentence, right? And pre-training is just about push more and more data through these models and get them to do next token prediction for more and more. And then amazingly, shockingly, like they get smart. They learn properties of the world. And there's more and more evidence about why they learn properties of the world. And maybe, there's this big debate. Are they learning world models? Are they not? To my mind, they're clearly learning world models. And, that I think that's closed, but it's very much not closed in academia and around the world. But pre-training is essentially this idea of, just keep pushing the scale. And like that does work. If you look at even the medium-sized models, people are pre-training them on vast amounts of tokens to make them great at what they do. But it's like the idea that you would just massively scale up pre-training, and that like the overall model intelligence or the model IQ was going to continue to dramatically improve. That, to my mind, is a core thesis that was in the world around the time that situational awareness paper dropped, which I think kind of encapsulated or became this kind of like Schelling moment or whatever. Like it became this focal point for the discussion. And I think like that naive thesis of just scale pre-training and that's the path to more and more intelligence, that that seems much less likely now. And it seems like we've several big data points against that. And like, people are still scaling up their compute and you're still doing a lot of like CapEx to do that. But it feels now more like what they're trying to do is they're trying to get good at reinforcement learning, which is like, so you've got the pre-trained model and, you do some post-training or instruction tuning on it to kind of like, make it useful, to make it be able to try and answer questions. And maybe the particular thing you do is you train it on a whole lot of maths proofs and you train it to like that, if you're given an instruction to prove this, you should try and produce a maths proof. Then after you get that, you sort of put it into a reinforcement learning harness where you're like, okay, so here are 1,000 maths proofs or 1,000 maths questions that I know the right answer to. Hey, model, go and generate like 10 possible attempts to solve this. And if one of them gets it right, that was a good one, right? Because I know the right answer. If one of them gets it right, that's a good one. Do more of that and less of the other things and just grind through that process again and again. The model.
And you're still talking about general purpose models here, not like a specialized maths model or anything like that. You're saying it picks these different subjects and grinds through lots of them and just generally gets better at all of them. Is that what you mean?
So typically what people are doing here is they are producing a general purpose pre-trained model, but then they're doing a lot of reinforcement learning on it. And then I guess you can debate the extent to which it then becomes a special purpose model as you do that, right? And this is an open thing. So there's been some really interesting stuff recently where people have made big progress on the International Maths Olympiad. And I think one of them, maybe OpenAI, kind of like said on Twitter, so it's not in a research paper, but they kind of said, hey, this is a general purpose reasoning model that's just, but is great at maths. And so, you can argue this. Like there was a rumor that GPT-4 had a whole bunch of like chess games in its training corpus. I don't know if this is true or not, but it's interesting intuitively because like learning to play chess would teach it basic reasoning. So like you're into this blurry thing about the extent to which these capabilities generalize.
I can't help but notice how backwards that is from how we taught chess to the thing, which is to not teach it chess moves, but to teach it like how to think in some fashion. And that was the breakthrough of getting AI to play chess really well. But now we're using chess games to teach it like broad reasoning. Is that?
Yeah. Maybe that was kind of an interesting.
If it was true, that'd be fun. Maybe if I take it back, okay, let me take us back. One of the cool things about doing this podcast is we get to do like moment in time predictions. I find it very difficult to rewind my brain and truly like live in a year ago. And so it's useful to be able to go back and look at what we thought. And I think you have I'd say you have a pretty good record of saying, I don't believe it's a blurry JPEG of the web. I believe we're seeing reasoning capabilities emerging. Good calls at the time.
Okay, yeah.
You're now saying, I want to go back to the world model you were talking about, because you're now saying, not everyone thinks it, but I think it already has a world model.
Yeah.
Let's take that as maybe a frontier prediction, something we could check back in a year's time or whatever. Talk more about what that would mean were that true, right? That these models do, or you were saying you already believe it does contain a world model. So explain what that means and what the implications of it are.
Yeah, I mean, that's honestly pretty close to the whole, like, is it a blurry JPEG of the web? Like, there's still a whole bunch of people out there in the world who are like, these things don't understand anything. They're just doing text prediction. And, I guess the alternative hypothesis is like, no, they're learning something about the world.
Can I ask you, is that a serious position that people who are serious about AI still hold?
Well, that's a controversial question. I would now say no, but there are absolutely a lot of very serious people who are in very respected roles and stuff that do sincerely hold that position. And I think that's tension in the world, and I don't know how it's going to resolve and stuff. Now, that's separate from the argument that, like, I think there's an interesting empirical question, which is like a scientific question. Do the current architectures scale to, super intelligence or whatever, right? Like we will transform it to the limit. I think that's a scientific question you can have legitimate opinions on. I think the evidence that they have some really hard limit, I find to be uncompelling. Whenever I see arguments of that form, and there's really famous people that have made them,
Yeah.
it always feels to me like an argument that, like, well, due to these limited properties of NAND gates, a general purpose computer clearly can't do something fuzzy. It's like, well, no, if you get enough NAND gates and put them together, there's this intermediate or this higher level of abstraction that can like run virtually on this limited low level hardware. And like, that's what we're interested in. What's the limits of that? And that's almost completely missing in the from first principles arguments about why transformers can't do X or Y. But I think this is very similar to like the blurry JPEG of the web style thing. Some people are just not going to be convinced. They're going to be like, these things can't reason, while the models engage in deep, real reason counter arguments to that, you know?
Yeah, yeah. Well, in some ways, it's probably an unwinnable argument, maybe in both directions, because it strikes me at least as like a kind of a rational question to a philosophical an attempt to answer a philosophical question in a rational way. You know what I mean? Like
Yeah, but they
anytime you ask someone, "Hey, has it got a world model?" You have to begin your answer with, "Well, yeah, it depends what you mean a by world model." No,
I disagree with your model of philosophy there, right? To get into the heady stuff, in that, like, I subscribe to this model of philosophy that philosophy is the study of questions that have not been sufficiently reduced that they are solvable. But any one particular philosophical question could be reduced, and so I actually think we're going to see like sort of empirical epistemology. We're just going to see domains that philosophers have argued about for like thousands of years suddenly become actually tractable. I think because of very deep questions of intelligence that are going to get resolved pretty damn soon, certainly in our lifetime.
I mean, this leads us back to the question of where are all the scientific breakthroughs or philosophical breakthroughs, perhaps? Like, especially for something like philosophy, where the input is going to be lots of writing or whatever, do you have a sense of why those haven't been produced yet? If that's your prediction, it's like these models can't, but future models will, or?
I think philosophy is a really hard one because it's difficult to verify.
Yeah. But there's no unit tests or.
No, I think that's the wrong domain to look for, convincing breakthroughs that everyone accepts these models are doing something novel. I think the right domain is probably mathematics, right? And it's like, but there hasn't been breakthroughs yet. Like we haven't seen a major problem fall to an LLM yet.
Yeah.
But I bet people are working on it, and I would be willing to bet that in some number of years, I bet DeepMind, this is kind of in DeepMind's wheelhouse, comes out with like, check it out, here's this millennium problem or something that like we now have cracked with the help or the partial help of an LLM or something. And I not in a simple computer aided proof. I not like the graph, not like the four color problem. But instead like hey, check it out. Let's check out these like novel, intuitive ideas that this massive machine that grinded through many streams of reasoning finally cracked. And yeah, was it like brute force or was it like intelligent? It's like way less brute force than good old fashioned AI. Way less brute force than DeepMind, or it's a Deep Blue, sorry, playing Kasparov. But it's doing an awful lot of search. But then it's like, well, how much search does a human brain do as they grind on a maths problem over 5 years or something, and like they go down blind alleys. But and I think you can even see this with like the recent work that they've done in this direction, right? Where it's like, it's doing a hell of a lot of search, like trying out different ways to solve the problem, but an awful lot less than you might expect, Like there's a lot of intuitively guided leaps in the reasoning models.
So here's a follow-on question. Like different humans have different brains. Like I'm, probably a lot more visually intelligent than mathematically intelligent or whatever, right? And that makes me better suited or whatever to different tasks. When you think about LLMs as brains, do you see those kinds of breakthroughs coming from big, broad, capable, frontier lab, GPT-6 or whatever,
Yeah.
or smaller, narrower, much more specifically trained? I guess my question I'm asking is, how do you see the landscape of the models offered and how they orient themselves. I'll put one more precursor to the question. It seems like one of the big pivot points of the year to me seemed to be like around February, right? When both the big labs like Microsoft and over, they were like $500 billion or something to build like giant data centers, which were obviously at the time a bet on pre-training continuing. And then DeepSeek happened like almost the same week, and which must have been like a major oh shit moment for them.
Yeah.
I like that in some sense signaled a break in the previous narrative we were on into an, oh, maybe the path now is on these more reasoning models, and that seems to be the way we've gone. Do you have any sense of how it'll go over the next year, perhaps, and where what those more specific models will allow for?
I think there's a lot in there. Like if we talk about the DeepSeek moment, it was good. It was a real thing that happened. It's not just like hyper BS or something. DeepSeek came along with like a really optimized model that was like very very capable. DeepSeek V3, say, very very capable, very good model. And a few things happened there. One thing was that they had this big bunch of quants who are like great at low level C++ programming and went and like hand optimized their particular hardware and got a whole bunch of performance improvements. And then also that they went and they published how much it cost them to train the model. So they legitimately did a lot of optimizations. That's a real thing. Uh, Separately, a second thing happened, which is that they kind of like pulled the mask off and pulled the hood off, and they were like, everybody, it doesn't take $500 million or whatever it might be to train a frontier model. We can do it for like 5 million for the training run. And I think there's an extent to which it suited the labs to like have this ambiguity around how much it costs to train a model. Because, and no, I'm obviously you got to separate out. The labs are doing all this R&D, so they've got all like the failed training runs and all the blind alleys and everything they go down. Like being in some sense the follower is easier than like trying to push the frontier and like search all these, and you can see that with like reasoning models, right? So DeepSeek very quickly followed on, V3 with like R1, and R1 is this reasoning model, and it's like even the proof of existence of a reasoning model gives you a massive hint that like that's the direction to invest in. And then R1's certainly very impressive. So there's a lot going on there. I do think that like the various labs, like the OpenAI, whoever else, Anthropic, like, it suited them for there to be ambiguity about, a crystallized individual frontier training run. How much did it cost? And the DeepSeek both produced a very good model, did a lot of really good hardware work, but also just kind of like pulled back the curtain on that a bit. So it's a few different things.
How do you think then DeepSeek and more what it meant, which was there's another approach here, how do you think it impacted all the frontier labs who they were more on a single track pre-training approach up until then, do you think, or with it?
No, I would say instead that like, DeepSeek was just a third party that was kind of like following the same template that they were following, but just pulling the curtain back on terms of like how much it costs. And they had a bunch of compute optimizations, but I don't know, but I kind of expect that they were probably less news to the frontier labs. They probably had similar compute optimizations. Maybe slightly better, slightly worse. I don't know.
So what do you make of the gigantic eye-watering capex that a lot of these large American companies especially shelled out earlier in the year to build huge gigantic data centers? And in many ways this is like the sleeper story, I think, of the tech industry at the moment, which is like,
Right.
we've been noodling along doing our websites and our SaaS stuff and so on, and now suddenly there is this like infrastructure project the size of multiple Apollo Manhattan type missions, huge effort, huge investment, a gigantic proportion of the US economy. Like I think a quarter of the Mag 7, the top 7 stocks are count for a quarter of the S&P 500. Or you were telling me Nvidia is some like gigantically outsized proportion.
Yeah, I don't remember exactly. Heading towards 10%.
Yeah. Do you think they made a mistake? Does that OpEx still apply in a post-training first world? And
Yeah.
what happens now over the next few years as the power comes online and those data centers that didn't exist so far in the AI world? Like, is that going to is that going to unlock the next dramatic set of changes? Or I guess I'm asking you to gaze into
Yeah,
the
yeah.
crystal ball now and look at that. It's hard to tell from the technology side, but there's certainly this infrastructure side thing is going to happen now.
Yeah, so I guess, I know a lot less about this than someone in a tech titan. I'm consuming public information sources and stuff, and trying to synthesize what's going on. And I definitely think there was like, if you believed the scaling pre-training hypothesis, right, and that like, multi-data center scaling and scaling your data centers are going to like, each time you go up 100x in terms of your pre-training compute, your model is going to get like 10 times smarter or some sort of logarithmic
Yeah.
returns. Then like it was probably economically rational to bet the farm on whatever it cost
Yeah.
to just scale. And so I think this is around the situational awareness time. People were talking about massive capex investments, and then like people like Microsoft started to like talk those down a little bit,
Mm.
right? And based on what I can see publicly, um, because I guess they had information that the pre-training wasn't scaling as well
Mm.
as people hoped,
Mm.
maybe. And then, but now I think it seems like it's back on again now to some extent, which is that, well, actually reinforcement learning works. Now, reinforcement learning works for a specific domain that you can get like good training signal on.
Mm.
And maybe it makes your model smarter overall. I don't know if I think the jury's still out on that, but it kind of works for like specific domains. Uh, I say the jury is out on it because there's some evidence that like OpenAI's IMO breakthrough maybe was powered by a general purpose reasoning model. Like maybe there's enough in reasoning, like reasoning generally, that is general, that like doing excellent reinforcement learning on just one domain or on some subset of domains will just teach you to be excellent at reasoning generally. We'll see. And like there's really interesting stuff in the research. There's like the Platonic representation hypothesis is getting some attention at the moment, which is this kind of idea that like different models on different training data sets converge to like similar representations of the world, that there's in some representation of the world or some subset of the space of possible world representations. There's some subset that is like useful for making predictions about the real world, and that like, models maybe converge in that, and that if you have like multiple overlapping problems that have become, as in you're trying to be good at maths, and you're trying to be good at computer programming, you're trying to be good at something else, that actually there is some like, Platonic ideal of like perfect reasoning that sits at the intersection of those
Mhm.
intersecting hyperplanes, and that, like, so you end up with like this exponentially decreasing set of ideal Platonic reasoning. And so that like, in other words, that maybe it's possible that these models will learn very general capabilities just by really grinding away on reinforcement learning from different specialist domains. So there's some argument for that. I don't want to discount that, but certainly reinforcement learning makes them great at a given domain, like mathematics or IMO problems, which is a subset of mathematics.
Yeah, yeah. Would that see the models become more similar in a sense, or do you see them diverging from each other?
I think a big surprising thing to me in the world, speaking like intuitively, is how similar the models
Right.
all are.
Exactly. Yeah.
Like that's a weird hypothesis a priori, given that they're trained often with like similar but different architectures,
Mhm.
right? So like different form of attention. We got using flash attention, using like vanilla attention, using something else. Uh, Different like model architectures, and that like, yeah, it's a transform, but it's kind of a different type, or it's a mixture of experts or whatever, and different training mixes and training data sets, different labs, different hardware, and then like the models are quite similar in terms of the capability. And I don't just mean that like in terms of their personality, because the personality is sort of post-trained in, and people are probably like training on each other's data sets, either by accident or surreptitiously or something, doing distillation. So I don't mean that. I kind of mean that like it's surprising that the core capabilities of models are like so similar across different domains. And it's also surprising to me that they're so similar to humans. Like they make mistakes that intuitively feel to me like often like human reasoning mistakes. And so, yeah, I consider that very, very weak evidence for the Platonic representation hypothesis. Much stronger evidence now exists for it. People like trying to align model representations and stuff. I think it's like Anthropic has this line of work, they call it scaling monosemanticity, and it's essentially using like training another type of machine learning model like sparse autoencoders to try and figure out like, hey, can I extract sets of neurons in this big network that map to some real world concept? And the remarkable thing for me is the richness of the conceptual models and the interpretability of the conceptual models they're able to pull out of that. Where
Right.
it's like,
This is a research project you're describing. This is not, when I'm talking to Claude, this is
"N-
not happening in the background. This is something Anthropic are doing. Is
yeah,
about me.
yeah, yeah, yeah. I mean, for all I know, they're using it to steer Claude or
Right.
something like that. But yeah, but this is certainly their alignment and their safety and
Yeah, yeah.
scientific work and stuff is to try and understand how the models do what they do, and like that's really cool work, and it's you know, and it's interesting,
Mm.
and for me, the weird, interesting thing is the extent to which you can pull human intelligible representations out of these models, and it's not just like, it is still
And
vast.
that is not a thing that it was ever trained on or was in its corpus of training. That's the
Yeah,
important
I
point
mean,
there, right?
I'm right. That is what, like, this is not when they're explicitly trained to do that. It's more like that, like, hey, implicitly, this is back to the world models thing. Implicitly, these things, just implicit in these very blunt training objectives, do seem to form rich, human interpretable representation of the world, or at least that there's some projection you can put it down on, so that's
Yeah.
human interpretable. Like, even that's surprising. Um,
I'm even wondering, is that surprising or not? Like, what to make of that? I mean, like, you can pull on that thread and think, oh, right. So a lot of these can be great scientists and great, and there's this emergent property that they could be maybe the great same type of scientist or whatever. And I wonder, does that just that point us towards around the early course towards discovering some universal law of physics or nature or something like that? Like, do you think, what do you make of the fact that they seem very similar?
Yeah, I think that if the evidence for the Platonic representation hypothesis mounts, I think it will be an extremely significant scientific discovery. The idea that, like, yeah, there is structure in some sense that
Yeah.
in the world, and that, like, you know again, this is this sort of like, hey, maybe epistemology will become an empirical discipline, right?
Mm.
Where, like, let's take a new intelligence that is very raw, and let's put it in a simulation, and then let's see how it constructs knowledge about the world, and like from that we can learn things about the patterns or the optimal ways by which knowledge is constructed from the world generally. That's very interesting stuff, and that ties back to this thing that questions that are very old in philosophy may switch to becoming questions of science. But as has happened with many other domains in the past, like, once upon a time, what we now consider physics was like way blurrier and less tractable, and so it was a branch of philosophy, and then it switched because we started to make progress. And the whole domains of like intelligence and just knowledge and all that stuff may switch in that same way. I think it'd be a very exciting time to see that if that happens.
It's wild to think that we may end up looking back on all this and thinking, networking all the computers together, digitizing all of the information. Turns out that the real important thing, which all seemed very important and useful at the time, was actually part of this very long term bootstrapping process towards maybe something like what you're describing,
Yeah, yeah, yeah.
Yeah, wild.
I know. I mean, I think so. I'm very bullish on AI. Now, like, maybe it'll hit some plateau or something like that. I don't think so. I think that there is so much overhang now in terms of like
Yeah.
application utility for the world, that even if the technology never goes any further, like that will fund continued investment and continued progress here for ages.
Yeah.
And so, like, yeah, could there be an AI winter? Sure, a lot of labs and stuff have extremely high valuations for products that are like, the Platonic representation hypothesis is like not great news for people trying to produce differentiated product offerings at the model's layer, right?
Can you explain that more?
Yeah, like, as in, you know, uh, so the a bunch of the Chinese companies like Alibaba and stuff, DeepSeek we mentioned before, they're producing very competitive models, really, really good models. And like, there is some extent to which, if it's like, well, a very large class of pre-training setups produce models that just pull the world representation out of the data. And, the data doesn't need to be that differentiated. You just need enough of it that it correctly starts to mirror the world. Like that to my mind is like bad news if your job is to, have a model that pulls signal out of the data and then you extract a return from that.
Oh, good news because you get awesome new tools to do your job. But is that what you mean, or bad news
Like
because
from a business
you're
strategy,
yeah.
from a business strategy point of view, from a humanity point of view, it's great news,
Right.
right? Because it means there won't just be one monopoly that has this. But there's still businesses to be built at the models layer, and the models layer is absolutely coming up the stack. And and I think like if scaling pre-training was the way to go, all the returns were going to accumulate to like, whatever company was able to marshal enough capital to like be the biggest, most scaled pre-training.
And that's why that race was on towards building the biggest data center.
Yeah, yeah.
Yeah.
And I mean, like, and that still could happen, right? Like, it depends on, like, so maybe scaling pre-training doesn't work, but maybe you get massively non-linear utility in return from investment, in like in the reinforcement learning stack, right? Like, X.AI seem to be on a massive scaling trajectory, right? They're like adding tons of GPUs. They say at least they plan to add tons more, and you like there is a plausible worldview, which is like you can simultaneously think that, the returns are diminishing, but those diminishing returns are also worth it. You can think that, right? You can be like, pre-training scaling doesn't really work, and we've got to do this more expensive, longer term, massive reinforcement learning grinds to make things smarter and smarter.
Mm.
And so, like, you got to commit tons of capital to do it to get like relatively small general improvements, but it's still worth it.
The way you're talking makes it sounds to me like what someone would say if they thought we were on the tapering end of an exponential curve. Is that where you are?
Well, we, so to my mind, like a year ago, or around the time the situational awareness thing dropped, right? Like that was it was kind of a terrifying time in technology and arguably for humanity, which is that like, you know, and I was never like, oh, this is definitely going to happen. I sent that paper around because I think chapter one in that had a really good review of the story so far. And then like, there was some chance that the scaling continued to work. And like, if the scaling pre-training continued to work, that was like a really weird, really scary time because it's like, a world where you just have a massive pre-training multi-data center run and like, who knows how smart the thing that comes out at the end of the run is. Maybe it's like this 250 IQ entity. Maybe it's this like 1,000 IQ entity. I don't know. Nobody knows, right? Like that's a really scary world, right? Because it's like what's valuable in the world like radically shifts. AI safety concerns become clear and pressing. Whereas a world where it's like, yeah, you pre-train it and it's like amazingly around human level intelligence, roughly in some sense. And then you use reinforcement learning to like massively specialize it. And, with reasonings, you can see all the chains of thought. That's a much more reassuring world. And you still don't know, are the chains of thoughts actually like what it's actually thinking, or is there like some.
Do you say it's more reassuring because there's some visibility into it's not such a black box, like it shows you its
Yeah.
chain of thought almost?
Well, it's more like it's kind of happening more slowly. There's more like human inspectable steps of the process.
Yeah.
And like there are some caveats, like the real chain of thought may not be the chain of thought scratch pad that you see, like you don't know for definite that.
They're tidying it up a bit before they put it in the UI, probably.
Yeah, and there's things to really watch for, which is that you put selection pressure on chains of thought that are superficially nice and safe, and then you like hide the real chain of thought and stuff. So like, it's not like AI safety is this like really really gnarly world. It's not at all solved, but at least things are moving a bit more slowly than they were in the like so I don't know if I'm willing to say that like things are tapering. Like empirically, what we've seen so far is that things are tapering in the last 6 months, last year. I don't know if I'm willing to project forward and say therefore things are tapering overall.
Or that other things won't pick up the slack, or
Yeah.
yeah.
I mean, like, the if you want to like roofline this, if you want to approach this from a first principles perspective, the amount of computation that's available in a big AI training data center compared to like a human brain,
Mhm.
like if you look at it just from a physical point of view, like the amount of power that's used is dramatically greater
Mhm.
to do the same thing the human brain does. And so like that could be reassuring because you go, oh, those idiot computers are way less efficient than us.
Mhm.
But it could also be terrifying in that you go like, therefore they have a 6 order of magnitude potential efficiency improvement from a physics point of view. And so maybe they could get way, way smarter. And so that's why like, you know, and like even the DeepSeek moment showed, at least publicly, that like, hey, you can go and get some really smart quants to hand tune, your key value cache or whatever,
Mhm.
and like get a big improvement. But like that's evidence that like, hey, there's big efficiency improvements on the table.
Mhm.
And I do think like, you know, these things are getting better at like maths, they're getting better at computer programming. And it seems like how efficiently can you train an AI model is something that's very amenable to a reinforcement learning, or like how efficiently can you calculate attention feels like something you could really use big reinforcement learning to improve on. So are there big improvements there? Are there architectural improvements? It's way too early to say. Like I don't think you can take a position that like, well, things have definitely tapered now, you
Mm,
know.
mm.
So yeah, I think
It does seem, I mean, we were very spoiled for a while, but also filled with fear by the dramatic increase in capabilities. But it does seem like on the product side, one thing I'm curious about is, let's take GPT-5's launch, which was last week, and to mixed feedback. Like in one ways, a big step forward, but it wasn't AGI, and some people are like disappointed because of that.
yeah,
On the other hand, it seems like they're now trying to like make this a real commercial product,
yeah,
make the thinking part of the model available to Joe public,
yeah.
without all of the overhead of model switching, which is a UX Achilles heel for them. And I'm just wondering, like, does that presage where we're going, or how do you see it evolve? See that changing, or
Yeah.
I guess what I'm describing is, it seems like we're now moving into an era where it's less just like free manna from heaven, free improvements like keep dropping into our lap, and now we're into working out gnarlier product questions, sometimes getting them wrong and having to roll back because of the customer feedback and stuff like that. And so that seems to me, I don't know, I'm just looking at that going, interesting. Is that a regular kind of little obstacle to navigate, or are we starting to see more and more of the signs of slowdown there?
I think you got to separate out a few different things. One is like the scientific question, which we've been talking about
Yeah.
so far, and the other is like the business reality for LLM labs. And I do think that Frontier Labs, they do have a problem, which is that their products are commoditizing,
Hmm.
and like that's definitely happening. Like, and you can see this with the open models, the open weight models, like from Alibaba or whatever. The delta between the best closed model that you can buy in an API and the best open weight model that you can host yourself, that delta is shrinking over time. And, you know, on most things that people care about, most general applications, maybe it's not on like winning IMO math medals and stuff. And you can get into like task saturation and all this stuff. But that delta is shrinking over time. And that's a big business problem if your business model is that you will burn enormous amounts of compute to produce a model that's like just slightly better, but then where like that massive capital expenditure becomes invalidated before you can get your reward from it. And so I do think you're starting to see like a strategic pivot in the top labs as a result. Maybe not, but I kind of get that sense. And so it seems like OpenAI is like going really on the B2C sense. And to my mind, GPT-5 feels like a B2C model, right?
Mm.
So it's like, it's capable, it's a really smart model. I don't want to talk it down, but like, it's really optimized,
Yeah.
right? And it's like, oh, it'll automatically discover when it needs to think and when it doesn't. So you get the benefits of the thinking when you need it, but you don't pay the costs when you don't. And, it's probably like very efficient inference stack underneath it. It's cheaper. And, that really feels like that's the model that if you're the massive B2C company and you want to scale your product and you want to keep your you want to get some measure of profitability, starting to get towards that direction. That's the kind of model you build. So yeah, so I think I do think that all the different labs are trying to, in some sense, verticalize or go up the stack in some area to like get a sustainable business. Anthropic, it looks like, is kind of heading more towards the coding
Yeah.
direction. And bad news for the, potentially the application layer companies for
Yeah.
Cursor on top of it. Maybe not, and we'll see.
Let's talk a little bit about the application layers and what the dynamic you just described means to them. So if the delta between the frontier lab models and the open source ones is shrinking all the time, if you're an application company, it becomes more and more um, attractive, I would imagine, to own your own model. And this is just, uh, I guess, a funny inversion of, if you think about the cloud era and everyone went from running their own server to like AWS and the cloud and centralizing all of that. Like, are we going to play that in reverse now, where rather than like everyone just hitting the frontier lab LLMs, they're gonna want their own on-prem LLM, or maybe not on-prem, but fine-tuned or trained even for their own purposes? Do you think we'll see more of that?
I think it will depend. I think that there's a lot of companies in the world that it'll never make sense to pay the technical cost of going and getting good at these things. I think that like if you want to be an AI company, I do think that like the what I would consider the AI layer, right? So like, maybe that's the model and like it's all the bits around the model, the orchestration, scaffolding, some people will call it. Uh, I do think that that layer is going to become increasingly important and where more and more business value is for a lot of application areas. I think you can see this with like, Cursor and Cloud Code play out. Like Cloud Code was like the model and the kind of the AI layer. Like I think so two things happened there. The first thing that happened was the AI layer, i.e. the model and its scaffolding around it, ate a big piece of the job. So like a lot of what you would need to use Cursor, you now could do Claude Code. There's a lot of stuff you couldn't, but it's some portion. And then Cursor just come out with like Cursor CLI, which is clearly a response to that, right? But either way, that's like the AI layer, so the model and the stuff around it, eating a chunk of the application. But at the same time, I think that the model layer is going to eat more and more of the AI layer. And I also think Cloud Code's a good example of that, which is that like, if you set out to build just the AI layer of a coding tool, a year before Cloud Code, you would probably build it in like quite a different way. But like then Cloud Code is this really a much simpler architecture. And I don't want to like they did work on it and everything. I don't want to talk about that. But like the model is a much bigger part of the Claude Code value than what you would have built a year earlier.
Can you just clarify that a bit? So you're saying that like when you're interacting with Claude Code, you're interacting with a slightly different, less constrained version of the model than when you're on, let's say, desktop Claude, right? Or you're now referring to like the terminal style UI that is wrapped around Claude Code, right?
Like Claude Code architecturally is almost certainly like two loops, right? Like an outer loop orchestrated by Claude, the model, where it's like given a bunch of prompts, given a bunch of tools that it can use. And then like, when it wants to do a specific thing, like read a file, it goes and uses the like file read tool and like has a model that goes and interprets the output of that. So it's very much like the Claude model orchestrating the Claude model to accomplish a given task. And there's a terminal interface around that you talk to the outer Claude model with. But like the application, the AI layer scaffolding around the Claude model is thin, right? Intentionally, and that's the thesis. And it works, right? And like that's an emerging architecture. And like a year ago, the models were probably not smart enough to work and to deliver sufficient quality with that simple architecture, right? So like we're just heading for this world where it's like, hey, agentic model, here are the things you can do. You go and figure out what to do. Whereas a year ago, it was much more like, hey, given models are extremely unreliable building blocks, I must use them as extremely simple building blocks and put everything I can around them, in like application scaffolding. I still to produce an AI layer. So there's two different things going on here. One is I think the amount of the AI layer that the model actually just drives is increasing, because that makes the models a bigger part of the picture. And then the second thing that's happening is the amount of the application that the AI layer delivers value for is also increasing. The AI layer is eating the application layer, and the model layer is eating the AI layer.
Is this a version of the bitter lesson, which the bitter lesson being this blog post someone, I forget who wrote a few years ago, which was basically saying that it's the models stupid. The models will continue to increase their... Is this a validation of that thesis?
I think the better lesson is a position paper from Rich Sutton, who's like
Okay,
a major guy in reinforcement learning. And it's basically this idea that, like, you know, data and general purpose compute like washes out specific kind of hand engineered things, and it's something to really watch. And, like, you know, there's the bitter lesson of AI application development that companies like Intercom have to absolutely not fall down the wrong side of. So I don't know if, I guess a strong bitter lesson position here would be that, like, over time the models are going to be where the value is, and, like, over time the models are going to eat. Well, sorry, no, let me take that again. A strong bitter lesson position here would be that over time the models are going to eat more and more of, like, the application stack around them, right? And specifically that general models will do this. And then a separate question is where the value accrues in that. Like, that's a separate, harder question. But I don't know if either of those things are true at the moment. You know, like, the bit of lesson here would be that the most general purpose models will win. And actually, it feels like we're kind of seeing some evidence in the other side, which is that, like, no, you need training data for a specific application to make the model great at that. Maybe over time, once again, more general models will win. But it certainly feels like we're in a sweet lesson part of the world at the moment. We're in a sweet lesson phase where it's like, no, you know, the, like, general models, but that are trained for specific tasks can get edge. And we see that as an Intercom.
We do, and then it becomes, I guess, about what the task is, and so the answer is it depends. Like, if it's coding, you're probably in a bit of a bind, to be honest, right? Because if those core models are very good at coding already and getting better, you have to add a lot of value. And this is like you mentioned the cursor example. I mean, this is where it's hard to strategically know what the right direction for them to go in, honestly, is, because
I think they must compete at the model there very rapidly.
Right, which is why I think what is their plan, apparently, as well. But I mean, it also kind of negates that, like, a very common pattern that you see is the model switcher, you know. And anytime you see a model switcher now, I think you're like, what is this layer being added other than, like, a nice UI for choosing between the models?
I think if you have a model switcher in your product, you're in a very strategically dangerous
I think so. So I also think you're in a dangerous UX position, because, you know, you can add GPT-5 to that list and someone can choose GPT-5. I don't think it works great out of the box if you just do that, right? And so
like, our experience has been that, like, hey, you can't build a model switcher in your product if you want to have, like, a high quality product, because, you know, and we don't want to talk too much about thin specific stuff here because it's supposed to be a more general thing, but just leaning on that experience, you know, anytime you change the model, if you want a high quality product experience, you got to, like, really sweat the prompts and change the prompts and do all this work. And so, like, a model switcher is, like, you know, generally, when I look at it, I get very suspicious that the product isn't an extremely high quality product.
it's more a playground, or
It's more a playground, or it's certainly not pushing to anywhere close to the performance envelope and to the edge of the performance envelope. But I also think that, like, you know, it's also a strategic problem if there's a model switcher, because it's like, well, you know, you've just kind of admitted that, like, your layer is relatively thin, you know. And I think they're two separate points, but I think they do correlate a lot for really good domain reasons. So yeah, so, you know, we'll see. Over time, I think you want to be running products that don't have model switchers in them. And there's probably some exceptions to that, but I think if what you have is an AI product, you generally don't want an AI product with a model switcher. If you have, like, some sort of a, you know, you're adding very different value. Maybe you're a logistics company and your core business is logistics, and then it's just this AI layer that's kind of like neighboring and it's nice to have. Sure, you can have model switchers and people can bring their own.
Right.
But then you know, you're not building a deep AI product at that point. You know, I think deep AI products shouldn't have model switchers.
I agree.
Yeah.
Yeah. Um, I gave you a bunch of credit, Fergal, for getting some of your predictions from our previous episodes being pretty spot on. So it's only fair that I should outsides this
Yeah.
and ask you, what are some of the things that you've updated your priors on, or things that you've changed your mind on, or things that you've just turned out to be flat out wrong about in
Yeah.
the past year?
You should get base points when you're right, but also when you're making it on. Yeah, look, so one thing that I was wrong about was, regulation in this space, right? Like, I think one of our previous podcasts, I was like, oh, I expect it to be like regulation around AI safety, and I expect it to be like hard and fast and stuff. And now, there is an amazing thesis which it could be that, like, well, because the whole pre-training scaling thing didn't work out, it didn't really make sense to do massive frontier regulation. We're on this like less scary safety trajectory than we were. And so maybe the whole machinery of the world really got that right. Or I think, unfortunately, much more
I
like,
don't think that's why they're focused in Brussels and not regulated. I know they've updated their priors on based on pre-training.
yeah,
It's changing.
I think we got lucky, which is that, like, not all the labs were nationalized, but also they didn't all need to be and stuff, and all those things worked out.
But why do you think the regulation didn't happen? Was it because they were labs are doing a good job of self-regulating? Maybe because the exponential curve is not so steep, or just a failure of regulation, and it should be. Do you think the regulation is still needed?
Um, I think we're on, like, with pre-training not scaling so fast, we're on a gentler slope than we might have thought we could have been a year ago. Like, if I was in charge of the world a year ago, I'd have passed some like pretty strong either regulation or like
Yeah.
observation, at least, of like frontier training runs, and an ability to like say, hey, wait a minute, maybe all that happened behind closed doors. I don't know. Um, but now, like, yeah, I don't think that's as
Yeah.
necessary. And I do think instead we've ended up with like regulation of like different sorts for all the other things that, like, I don't know if it's worth it,
What are you
Or like,
hearing?
the EU AI Act
Right.
stuff,
Okay.
right?
Yeah.
I just don't know. Like, we're encountering it now and stuff, and I don't know who it helps, right? And like, you know, I don't know if those trade-offs are worth it. I mean, obviously, I'm super biased as someone running an AI thing, but if I can try and talk as a citizen or something, like, AI is going to be this possibly, but I think AI is going to be the defining industry of the foreseeable future,
Mhm.
and Europe's making it a lot harder to move on it, and like, to my mind, relatively marginal gains in terms of like
The safety
the
gains.
safety gains or the ethical gains or whatever people care about, GDPR, AI Act. I think, like, they had this thing recently, and this could totally get cut from the podcast. They did this thing recently, like the EU AI code of practice or something like that, and it had like three pillars, and this like big pillar was all about like copyright and so on. And like, yeah, like, people who produce work have to be able to earn a living. I totally get that, and that's a good social contract. Um, but in the United States, they're like having case laws and stuff, and saying, "Oh yeah, it is kind of fair use to train a big model." And like, I think that's a great position. And like, Japan has like said, like, yeah, it has passed legislation saying you're allowed to train models. And I'm like, I take a position on this. My position has evolved. I think you should be allowed to train models on copyright data in the same way that, like, you should be allowed have a human read a whole bunch of books and, write a new
Yeah.
book. Now, then you can't clone the copyright work, right? That's bad, right? You're stealing someone else's work. Um, and like, maybe there does need to be a change in the social contract, for like, creative folks to still get paid somehow. But like, I if you told, so I don't know, someone needs to think about this. But if you said, Virgil, you're in charge of all this stuff, like, I wouldn't knee jerk take the position that like training an AI model on something is stealing it. I would instead like be like, no, I don't see that. I think it's learning. It is legitimately learning in a transformative way. Our existing social contract is that, like, you're allowed to learn from copyright work. You don't owe an author a royalty if you're inspired or you learn from their work. You do if you steal their work. And like, the test for that is to do with like similarity of output. It's not to do with like whether they were
Which is probably more testable as well. That's more than
That's
straight up
so-
copyright law,
yeah,
which is like a way stickier problem, I would say. You know what I mean? Because I broadly agree with what you're saying, by the way, and like largely because that's what creative pursuits are about in humans. It's about ingesting a load of information and then something tumbles out of your head in a somewhat hallucinatory way. That's what creativity is. Everything is a remix.
yeah.
I believe that a lot, but and so we should probably hold roughly the same standards to this stuff as well. And is this novel versus is this just regurgitating someone's work, for free?
Yeah.
Surely seems fairly testable and verifiable. And
I mean, I do want to say, obviously, if you're a creative person and,
Uh,
like,
it sucks.
it sucks.
Yeah, it
Right.
does. I want to say that too. It does suck, but
And there probably does need to be a renegotiated social contract around that. I don't know if that means basic income for artists or whatever that means.
yeah.
But like, I mean, if you're a coder and, you have through the sweat of your brow produced an open source library and you've made it open source and like, so you own the copyright on that, say, right?
Mm.
And we've an open source license. If someone goes and trains an AI model on it, like that will, compete with you down in the market afterwards. And, it's, it's a legitimate position to be like, hey, that sucks too. But I don't think copyright is the way to, enforce that,
Yeah.
Now, yeah, I mean, maybe like, it's complicated. It does need to be figured out, but just not in a super blunt way. And I do think that, like, if the EU as a whole decides that the way we're going to deal with like AI training is in a very blunt way that basically makes it infeasible, then like Asian countries and the US are going to like dominate this massive industry, and like there'll be a lot less basic income. There will still be. And
Yeah.
like the other thing is that, AI model training techniques get better over time. Like at some point it will become possible to train an AI model purely on works that are out of copyright, like old works,
Yeah.
and use that for like style. And then like train an AI model on like massive amounts of video on the world and use that to teach it like about the shapes of things. And then like, with a relatively small investment of time, like guide its art style in a way you want. Like, you could build an entirely not, use no copyright information, AI art model. I don't know if anyone's done that, but I know you could, or at least theoretically. That's going to come at some point. And then like, if your whole strategy is to regulate things based on copyright, right? Well, that was not a good strategy at that
Yeah,
point, So yeah.
I think the conversation is more to do with copyright than AI, to be like copyright law. And for many years, people have talked about the problems of copyright, and a new technology like the internet comes along. And there was a lot of debate. Remember Lawrence Lessig, the professor, and Creative Commons, and there was a lot of debate on the internet about copyright 15 years ago. And I think it's more of a version of that with copyright than AI. But yeah.
Yeah, copyright always makes me uncomfortable. It's like it's Disney or someone, like, say people can like lock IP monopolies and stuff. Like, yeah, it's definitely a compromise, and I think it should be judged on whether it's good overall.
The democracy of IP law, which is like it's bad, but the least bad of it. Yeah.
For every book, it's a copy.
For my part, I feel like last year I was really excited about the new UI stuff that was going to happen. I'm more of a product person. That's the lens I'm bringing to this and so on. So I was expecting lots to happen as regards kind of like prompt engineering kind of going away. It seemed like a very caveman-like way of interacting with the computer. And I was waiting for maybe generative AIs to give me loads of knobs and dials to like edit my images and stuff like that.
Yeah.
And none of that has happened. So I was totally wrong about that. And I, in retrospect, I think I was just straight up wrong about like prompt engineering should go away. Having done a lot more of it myself over the last year, I realized this is the new way of interacting with computers, and we can make it better. But it's pretty great in many ways already. The generative UI thing, I think, still is so obvious. I'm waiting for it to happen, but I think it hasn't had the right necessity or form factor in it. Let's say you've got a SaaS app. What part of that do you suddenly need generative UI to like appear in? Not much, but if you're a chat app, for example, you might want to, and you're starting to see little carousels and things like that appear in some of the chats with LLMs.
Yeah.
But maybe I also have a feeling that like there'll be a whole bunch of wearables and glasses and so on that come in the next few years that feel more native, or that finally give us our native AI UIs, if you will, and maybe we'll see like the generative UIs, because it doesn't seem like that's hard of a problem.
Yeah, yeah.
Just waiting for the right confluence of the form factor, whether glasses or whatever, and the model that can actually do it, and the use cases.
I think economics is a big part of this actually. Like I would settle for my Star Trek communicator that I could just touch and then get access to a frontier model. But I think it's just challenging to ship that to the world from an economic perspective at the sort of scale that a device like that needs. Because it's kind of like, well, why doesn't my Google Home talk to Gemini?
Yeah.
Right. And it's
Yeah.
because it's going to cost a lot whenever they do that.
Yeah, yeah.
So yeah, so I think that is a factor.
We got to keep building those data centers, I guess.
Yeah, well, I
Yeah.
think they do. I think yeah, there's going to be a lot more data centers in the world in all futures.
That might be a good as point as any to wrap things up. Maybe we can come back in a year's time and see what how many of our current predictions have come to pass. But yeah,
Absolutely. Thanks, Simon. Thanks for the conversation. Yeah, I'd love to check back in and see how it fares.